So a queue is a data structure composed of nodes where the new items are added to the tail of the queue and existing items are removed from the head of the queue. So in other words, a queue would implement first in, first out logic. So in my code, I'm going to be having 3 classes. So I'm going to be having a queue class, which manages the queue access logic, the node class, which forms the structure of the queue, and a data class, which defines the content of the queue. And I'm going to be implementing these properties. So I'm going to be implementing head and tail. These are reference variables to a node. Since items are removed from the head of the queue, the head will be used to remove items from the queue. And also, head is basically the same thing as top. So the head is going to be used to keep track of the top of the queue. Since the items are added to the tail of the queue, the tail will be used to add items to the queue. And also the tail is going to be used to keep track of the bottom. So I'm going to be implementing these methods in a queue: an enqueue, a dqueue, and a peek. An enqueue is basically an add method. It's going to add to the tail of the queue. A dqueue is going to remove an item from the head of the queue. And a peek gets a copy of the top item, but leaves the item on the queue. I'm going to be going over the algorithm of the enqueue method. So we're going to start off with an empty queue data structure. So in that queue, we're going to have head and tail properties or reference variables, and they're going to be pointing to null. So if we want to enqueue a node into the queue, we have to instantiate that node. So we're going to instantiate that node with a temp node reference variable. So the first step is to instantiate and the temp node pointer is helpful for keeping track of the location of the new node we're trying to add. So if we want this temp node to be included in the queue, we're just going to have to set tail to temp node. And then we don't want head to be pointing to null by the time we end this enqueue. So we're going to have to point, because if it's pointing to nothing, or if any reference variable is pointing to nothing, it's going to get lost. So we're going to set head to where tail is. So if head is null, and this is a special case because the queue stack was empty the queue was empty when we first did it. So since tail and temp node are pointing to the same node, we don't need temp node anymore. So we have head and tail both pointing to node. And also, node tail.next is pointing to null right now. Okay, so we want to add another node to the queue stack. So we're going to instantiate a node with a pointer. with a temp node pointer. But we can't set tail to temp node because when we add something to a queue, if there's already going to be an item to it, we don't want to lose any nodes if there's already going to be an item to it. So in order to keep track of where all the nodes are, we're going to attach next of our last node to the new node. So tail.next is equal to temp node. By doing this, we're linking the nodes to each other, so we know where the next node after a certain node is. So this is the condition if tail is not null, and that's when the queue has nodes when we're trying to add it. So not if the queue is empty. This step doesn't seem necessary because we only have 2 nodes and we're just linking 2 nodes together, but it's very helpful for a lot of nodes. So temp node.next is going to be pointing to null. So we set tail to temp node. And because tail and temp node are both pointing to node, we can disregard temp node. And we can skip this step. So if we want to add another node, we're going to instantiate a node with a temp node pointer. And we're going to set tail.next to temp node. So we're going to link this node to the temp node. So, and then we set tail to temp node. And they're both pointing here, so we can disregard temp node. So now I'm going to be dequeuing or removing nodes from this current queue. So we're going to be in the queue, you remove items from the head of the queue. So instead of my temp node pointer from the end queue, I'm going to be doing a dequeued pointer. So I'm going to be set dequeued to head. And it's going to help point to which node I want to dequeue. So I want to move head to where this is. And luckily we have somewhere, we know where this node is because this is where head.next is. So I'm going to set head to head.next. And this is why the next is very helpful, because it helps tell us where the next node is. And then I want to disconnect the arrow between these so it's removed it's removed completely. So I'm going to set dequeue.next, so this arrow, to null. So it's removed from the queue. So basically, this would be the same thing as having no node. Okay, so we set dequeued to head. If we want to remove this node, we would set head to head.next. So head.next would be where this arrow is pointing. And then we would set dequeued.next, so this arrow, to null. and that would disconnect it from the queue. Okay, same thing. We would set dequeued to head, so the node we want to remove. We would set head to head.next. So head to head.next. Head.next is pointing to null. So head would be pointing to null. And then we set dequeued.next to null. That's no change. But we don't want tail pointing to anything, because that kind of means that this node is still in the queue. So if we want the queue to be empty, head and tail should be pointing to null. So we set tail to null. This case only happens if the head is null. So we set tail to null. And basically, this is not in the queue anymore.